purpose of this presentation is to highlight basic concept of wind generation, describing wind resources, explain the technology, show the process of building wind farm, illustrate islanded system, and demonstrate the economic questions. You know, the wind power is one of the successful story of renewable energy. You know, if you look at the development of the wind power worldwide, and you will actually agree with me that this is a success story of renewable energy. I show you the the market of wind power is dominated by three regions: North America, Europe, and Asia. When I say Asia, I mean India and China. The rest of the countries of Asian countries, or no, they are not active, but China and India extremely good and active in using wind power. And I was reading a report outside China that they say they have gone so fast in terms of development of wind power and wind farm that they have problem, because structure has not actually is not able to absorb the amount of wind power that they produce. So I'm sure they will be able to solve it, but they have gone very fast. You know, people rushed to use wind power. You know, this is the global status of wind power until 2014, and you can actually see how fast the world is moving towards renewable energy or wind energy. I wish that you know, the stupid statement made by Prime Minister of Australia said wind power is ugly and is noisy and not healthy. I wish actually he could actually see this diagram, how the other part of the world outside Australia thinking about or have attitude about the wind power. It's not, he might actually say it ugly and noisy and unhealthy, but other parts of the world, they think differently. And you can actually see in 1996 until 2014, this is about 18 years, has increased from 6 gigawatt to 370 gigawatts. And 370 gigawatt wind farm capacity is equivalent to nearly more than 300 nuclear power stations of 1,000 megawatts. Well, you can actually see how is developing. And this one shows actually every year in 2013, 2012, how much new wind power came to the market and connected to the grid. And yeah, this is also actually development or new installed capacity of wind power worldwide. 10 years, 15 years ago, the manufacturer of wind power, they actually used to produce wind turbines under 1,000 kilowatt. For example, Vestas or Suzlon, European and Indian wind power manufacturer, wind turbine manufacturer, is used to produce 330 kilowatt or 660. But now they are talking about 5 megawatts, 7 megawatts. Hyundai in South Korea, they are talking about the 11 megawatts. You know, they make bigger and with a higher capacity. And you know, 11 megawatts wind turbine, probably they have diameter of something like the jumbo jet 747, so big. And as I said, they actually used to manufacture small wind turbine, but now it's become bigger and bigger and bigger. bigger because the amount of power that a wind turbine can produce is proportional to the diameter of the wind turbine swept area squared. So I don't know, in 2020 probably is 20 megawatts wind turbine will be commercially available. And the 20 megawatts of wind turbine, if you want to imagine 20 megawatts, even if wind turbine works at, say, 30% capacity factor, can actually generate, one single wind turbine can generate enough power for at least 1,000 or 2,000 houses, depends on the amount of actually consumption of the houses. And a wind turbine has some important components like nacelle, tower, foundation, control system, transformer, and electrical connection. And the theory of the wind power says that the amount of power that a wind turbine can produce is proportional to speed of the location where the wind turbine is installed to power 3. It means, for example, if one wind turbine is installed here in Marrakesh, with where average wind speed is 4 meters per second, and same wind turbine installed somewhere that the average wind speed is 8, the amount of power will be increased by a factor of 8 because it's proportional to speed to power 3. And for students, actually students working on this, and this is the equation we use for performance prediction of wind turbine. But remember, in this equation, the speed is instantaneous speed. If you want, usually we use the average of wind speed for performance prediction, but we have to use another formula. And this is actually example what I told you before. For example, if a wind turbine is installed where wind speed is 8, or same wind turbine installed in where speed is 16, it means wind speed increases by factor 2, but the amount of power increases by factor of 8, 2 to power 3. So it is very important for the wind farm developer to investigate, to spend money, to spend time to find the appropriate, good location for wind farm. So as I said before, as wind turbine, the capacity of wind turbine or size of wind turbine increases, the length of blade increases, the length of tower increases, and the amount of power will increase. There are two different types mainly used, vertical axis or horizontal axis. But horizontal axis wind turbine are more popular than vertical axis. And the main disadvantage of wind, each technology, horizontal or vertical axis, they have advantages or disadvantages. But in terms of visuality or the looking, the horizontal axis wind turbine are more popular because it's good looking, and mainly manufacturer, they have decided for 3 blades. I have seen 1 blade wind turbine or 2 blade wind turbine, but 3 blade wind turbine is more popular, and also almost all manufacturers agree to make it 3 blade wind turbines. And they are actually 2 different, again, in terms of type. There are 2 upwind machine and downwind machine. When wind turbine is, or the blades facing the wind direction, they are called upwind machine. Or there are also wind turbine that working on downwind machine. It means working when blades are not facing directly the wind direction. this one animation doesn't work. I don't know. But anyway. One is a very important factor in terms of the wind farm or wind power production is capacity factor. Capacity factor is defined as the amount of energy that a wind turbine can produce in 1 year divided by rated power of wind turbine multiplied by number of hours per year, which is 8,760, the capacity factor. And if, for example, capacity factor is low, it means developer, they have done a mistake, they have chosen a wrong site. When capacity factor is 40, 45, 50, that is actually ideal site for wind power. Yeah, I said this one before. So if, for example, one location has relatively low wind speed, average of wind speed is relatively low, 6, 5, 7, probably is not as a good idea to have to install or to develop wind farm. And wind farm or wind power or wind turbine is not a new technology. Is, you know, this is actually one of the sources that I've used to prepare this presentation shows wind turbine first in 1880. Is about 100 or 135 years ago. So this is actually shows the picture in wind turbines in 1930s, 1940s, 1950s, 1970s, and 1990s. As I said before, most common design used nowadays is three-bladed because it's nice looking, upwind, and horizontal axis. There are mainly, you know, the wind turbine available in the market. Pitch controlled, a steel tubular tower, and availability nearly 100%. It means almost all manufacturers of wind turbine, they agree to have this type of wind turbine. And it has a very complicated, very high technology in it to convert a wind power or power of the wind into electricity. And also they are subject to damages. You know, it's a couple of pictures showing that the wind turbine has been damaged or fire in the nozzle and so on. So because they are it's obvious because they are outdoor facility, they are not indoor facility, and they are subject to natural disaster. And as I said, the site, selection of site is very important because must be wind power, wind speed must be big enough to generate enough electricity, because wind farm developer, they are looking for size of dollar. They want to maximize the power and minimize the cost. And there are actually many costs involved. Unlike solar energy, this technology requires some maintenance. Solar energy doesn't require maintenance, but this one it does. And usually, wind farm that I have visited in Australia, they are mainly operated by a part-time operator. Now, it doesn't need one full-time person being there. One part-time person can actually run the wind turbine and look after it. What is very important is economy of wind power. Now, what method we use, or my student actually use, what they do, they calculate or predict, because for wind farm developer, it's very important to see, okay, if they install a wind farm in a place A, what would be the total cost over 25 years, and what would be the dollar per kilowatt hour of the electricity. So we have to calculate kilowatt hours in 1 year, and we have to calculate the cost per year. The cost per year is a installation cost, depends on, these days in Australia they talk about the $1,500 per kilowatt. So, but is the installation cost upfront cost and then maintenance cost? Maintenance cost is not very expensive. As I said, it requires just one person to look after. So in order to find the economy, or to analyze the economy of wind farm, we have to calculate kilowatt hours in 1 year, and we have to calculate annualized, considering time value of money in 1 year, and then we calculate the dollar per kilowatt hours. As I said, this actually list shows you the cost, different costs of wind farm that we have to consider when we would like to do cost analysis. And what is important from the developer point of view, I have developed a computer program, and this it tells you actually, if you want, as a developer, you want to decide what turbine to choose, then my software computer program tells you what is the best actually wind turbine commercially available. I have done for many wind turbine manufacturers, Suzlon, Vestas, and so on, and I show you, for example, which one has a better production and better capacity factor. But please don't tell to the Vestas or Suzlon that I have compared these two. I probably get a problem with that. These are actually 8 different wind turbines. I hope that I forgot to remove the name of manufacturer because it is commercially sensitive. But I have selected 4 Suzlon wind turbines from India and 4 Vestas wind turbines from Europe. And they have, when you visit a wind farm or wind turbine manufacturer, or you buy it, they give you actually all characteristics of it: cut-in wind speed, cut-off wind speed, rated wind speed, and so on. And these are actually two, in order to compare the performance of 2 different wind turbines or different wind turbines, there are 2 factors are very important. Factor number 1 is capacity factor. Capacity factor, as I said, gives you idea the actual power that a wind turbine can produce in 1 year. The higher, the better. Then anything below 40%, forget it. I visited one wind farm near Canberra in Australia, and the operator told us most of the year the wind turbine were not working. Probably wrong decision, wrong place, or politically issued, someone has money from government and installed a wind farm, wind turbine as wrong place. But the higher capacity factor, anything below 40 is better, forget it. The other one is utilization factor. I said there are 3 wind speeds are very important. When you visit Vestas, for example, Suzlon wind turbine manufacturer, they tell you 3 wind speed, 3 or 4 meters per second cut in. Anything below that, wind turbine will be locked because the amount of power that wind turbine generates is not covering even maintenance costs. So cut in and rated wind speed, it means when you buy actually one wind turbine, say rated wind speed is 14 meters per second, it means if wind speed is 14 meters per second, then it's wind turbine can operate at its rated power, 5 megawatts, 6 megawatts. And cut-off wind speed, when wind speed is very high, and say usually 25 meters per second or 24 meters per second, the control system stops in order to avoid damaging them. So these are actually important wind speeds that we have to consider. And I said I have selected some wind turbine from 2 different manufacturers. And before showing the result, I want to tell you one thing. When you measure the wind speed in 1 year, say, for example, usually wind speed between 3 and 25 are reasonable wind speed. Anything above 25 is dangerous. Anything below cut in, which is 3 to 4 meter per second, also unreasonable. So if for example, measure how many hours in 1 year wind speed has been 3, 4, 5 meter per second, 10, 20, until 25, you will get a curve like this. It means this horizontal axis tells you the wind speed, and vertical axis, the number of hours. For example, here, say, number of hours in 1 year that wind speed has been 2. Or number of hours, 5, is about 750 hours in 1 year. Now, how to, this is actually, no one is interested to sit down and measure wind speed for 1 year. So we, as a mathematician, we see how we can create a mathematical method. Look at these 3 curves or 4 curves. They are known as Weibull PDF. Yeah? And there are 2 factors in that equation, and the factors are shape factor and a scale factor. As you can see, when factor is k is 2, is very close to what reality happens. Yeah? So I show you the equation. This is the top one is the equation here. Yeah? This is the equation that gives us the curve. But there are 2 factors, k and c, and the factor when k is 2 is much closer to the reality. Factor 2 is when factor k is 2 is much closer to what in reality happens. So for performance prediction, we are not interested in, or no one is interested in, instantaneous wind speed. We usually use average of wind speed in 1 year. Bureau of Meteorology, any country, they give you the average of wind speed of any location of any year. So we have to do some mathematical calculation to generate a wind speed. So you can actually say, using this equation, you can say, okay, Morocco wind speed, average wind speed in 2014, or usually they give you average for 10 years, is 6 meters per second. So you can generate wind speed by using the average of the wind speed of the location, which is actually gives you idea to in order to see, okay, location is good, capacity factor is reasonable, utilization factor is reasonable. I said capacity factor is the actual amount of power or energy, kilowatt hours or megawatt hours that a wind turbine can produce in 1 year, divided by rated power multiplied by number of hours in 1 year. On utilization factor, it says how many hours in 1 year, or utilization factor is, again, the percentage that wind turbine is operational. I said there are actually wind speed below cut-in wind speed and above cut-off wind speed. Wind turbine is not operational, not working. So we can actually, by using this formula, by using mathematical model, we can determine how many hours in 1 year the wind turbine is working and is positively generating power. This is 2 factors that we have to, in order to compare, to choose a good wind turbine, we have to consider. When you look at when you visit one of the manufacturer of wind turbine, they give you a curve, they call it power curve. Power curve, as I said before, these are 3 important wind speed. Anything below is not useful, so the wind turbine will be locked, not working. Anything above cut-off wind speed also not working, because in order to avoid the damage to the wind turbine, but operating point moves on this curve. And rated wind speed is when a wind speed is equivalent to rated wind power, then rated wind speed, then wind turbine can produce its rated power, whatever it is, 5 megawatt, 10 megawatt, and so on. So in that curve, in order to bring that curve into the mathematical equation, we can say that in this, when wind speed changes, the formula will be used. Okay, now, so these are actually 8 characteristics of 8 wind turbines that I used. M1 is manufacturer number 1. I tell you it's Vestas, but you don't tell anybody else. And M2 is Suzlon, but I call it M2. And these are characteristics. When you visit the website of wind turbine, gives you all cut in, cut out, cut off, or rated wind power. And the last column is the size. I intentionally use similar size to see which one is better. Okay. M23, this curve gives capacity factor. Now you can actually say, okay, this one is a Suzlon wind turbine. M23, size is 2.1 megawatt, has a better capacity factor. That wind turbine with a better, higher capacity factor, it means lower cost. Dollar per kilowatt hour is smaller. But as you can see, that this particular wind turbine perform better, generate more power, and will actually generate more money for wind farm development. And these are actually utilization factor, very similar. The utilization factor of these 8 are very similar, not significantly different. And again, the reason that the Suzlon wind turbine performed better, you can see in here. It says, in 1 year, that particular wind turbine, in 1 year, has been actually operating between rated wind speed VR and cutoff wind speed. That is the perfect, the ideal is that wind turbine operate on the flat section, flat power curve. And in terms of the, again, wind speed between cut-in and rated power, not much difference. Is 5, for example, again, that particular wind turbine, 5,553 hours has been working when wind speed is between cut-in and rated power. It makes sense because this wind turbine was mainly operating during the flat region of the wind power. So it has been working less in cubic part of the curve. And one more thing I want to mention here is, again, focus on this and compare these 8 wind turbines and these numbers here, 11, 14, 6, 8. Remember the power curve is the reason actually that particular wind turbine working better and has higher capacity factor because the length of flat area is big. Remember the power curve? And that particular wind turbine has longer, the difference between rated wind speed and cutoff wind speed is bigger. There are many evidences showing that this wind turbine is working in better.
Professor Ahmed.
And this actually, sorry? Yeah, I will finish in very soon. How much time I have? 2 minutes?
2 minutes.
To summarize?
2 minutes.
Okay. And Okay, capacity factor. Again, capacity factor against the length between rated wind speed and cutoff wind speed. Okay. In conclusion, I want actually, what was the purpose of doing this? You know, this is very useful software program for wind farm developer. You know, usually they want to choose the best location, more higher performance, higher capacity factor, higher utilization factor. So what I have done, I just compared 8 different wind turbines, but can be used for any, as long as you know as long as you know the characteristic of wind turbines, cut in rated power, rated wind speed cutoff, you can actually compare with them. So this software program is mainly helpful for wind farm developer. And in conclusion, the evidence is showing us that even 2 similar wind turbines perform differently. These 8 wind turbines, they are in the range of 2 to 3 megawatts, very similar in terms of size, very similar, but they perform differently. So if you decide, or one of your college friends wants to develop a wind farm, it's better to do carefully, examine different performance of different wind turbines to get the best results. As I have finished in terms of time, so I better stop. Thank you very much.